The planet we call home is an extraordinary place. Earth's oxygen, water, temperature, and atmosphere have woven a rich and complex web of life, teeming with living species, many of which have yet to be discovered. We are part of this rich natural ecosystem. It's vital to the health and prosperity of our very own existence. But human activity and development have put the world's magnificent biodiversity at risk. Species are disappearing, wetlands are threatened, and oceans are in decline. Protecting and maintaining Earth's biodiversity is not only important to the millions of species that call it home, but to the future of humanity itself. To protect nature and its biodiversity, we must monitor and analyze its health. But we can't solve problems that we can't see. And collecting data is a manual and labor-intensive process. Right now, the world's scientists don't have enough of, or the right, data to get the full picture. This is where technology can help. Microsoft is building a planetary computer powered by Azure Open Data to help scientists from around the world monitor, model, and manage the planet's natural resources. A massive treasure trove of data that can be accessed and updated anytime by anyone, anywhere on the planet. This will require a global network to connect trillions of data points about the environment. Data that will tell us more about forest cover and carbon sequestration, crop yields and changes in glacial ice, harmful algal blooms, the health of penguin colonies, and so much more. Data that will become actionable insights that tell us how to prioritize, preserve, and protect animal and marine species, forests, waterways, and ecosystems around the world. This will require enormous computing power and some of the most advanced machine learning tools and algorithms in the world to process it. Time is of the essence when it comes to protecting the planet. We must ensure that while humanity moves forward, we work together as one to minimize our environmental impact. With more data, computing power, and machine learning, we plan to do just that.
Okay, so hello again, and good afternoon, everybody. Welcome again to another AppDev Tech Talk, a lunch and learn session for our UK professional services community, and the target audience is our developers and software engineers. So this is the sixth session I've hosted in this format, and it's third that we've done in the last 4 weeks, so we're getting good cadence. I've listed here the topics that we've previously covered, and the recordings are available to play at that link. Microphones are currently disabled, but we will enable them at the end for any questions. But along the way, please use the chat. And then if anybody can help contribute to answers and discussion, that would be helpful and appreciated. If any questions are not fully answered or get missed in the chat, then please repeat at the end when we open up the mics, or send them to me afterwards. And then as usual, a recording of today's session will be made available at the above link, and also posted with the recording will be a link to the slides. And so today's agenda, our topic is going to be green software engineering. My name's Mark Harrison. My role is an Azure AppDev specialist. I'm part of the various account teams that are working with our customers in the UK professional services sector. So I sent out calendar invites to the organizations that I am aligned to, and my contact details are on the screen. And then with these calls, I aim to get subject matter experts to support. And for today's session, it's a great pleasure to be joined by Paulo Ane, who is a cloud solutions architect, team manager, and a green software advocate. So I'm going to kick things off and talk about the problem we are trying to solve and why we must act now. And then Paulo will pick up and dive deeper into the topic of green software engineering. So starting at a kind of high level with a suggested definition of what sustainability actually is. So sustainability is about meeting the needs of the present without compromising the ability of future generations to meet their needs. And sustainability is often broken down into these three pillars: social, economic, and environmental. So social sustainability is about the betterment of society. Economic sustainability is about creating value out of whatever you are undertaking. And then environmental sustainability is about looking after the planet. And the three categories are kind of intertwined, and weakness in any one pillar will have a negative impact on the other pillars. And experts will say that sustainability can only be truly achieved if all three pillars are looked after. And then the member states of the United Nations have adopted this kind of blueprint for peace and prosperity for people and the planet now and into the future. At its heart is these 17 sustainable development goals, and within that is 169 targets. And these highlight that ending poverty and other deprivations must go hand in hand with strategies that improve health and education, reduce inequality and spur economic growth, while all tackling climate change and working to look after the planet. And most major companies now will have a sustainability strategy, often referred to as a CSR, a corporate social responsibility. And it's a publicly communicated statement in your annual reports and on the corporate website. And there's a link there as an example to the Microsoft CSR, which outlines our commitments and progress. So the UN goals aim for a world that is fairer, more prosperous, and respectful of the environment within 10 years. And with regard to the environment, the UN that we kind of warns that we are running late, and the question now is whether we have time to save the planet. And protecting environment is an essential precondition for social justice and economic development. If we do not achieve these goals related to clean water and sanitation, life below the water, life on land, and climate action, the world will fail to achieve the remaining goals. But we've got a problem. So this graph here is showing how global land ocean temperatures are changing. And it's using the temperatures of 1951 to 1980 as the base of zero. And it's showing that deviation from that base. So 19 of the warmest years have occurred since the year 2000. It's gone up 1 degree from the 60s and approximately 2 degrees from the 1860s. Now, 1 or 2 degrees might not seem that much, but the concern is the rate of change and the direction of travel over the last 20 years. So the planet is getting hotter. It's on a trajectory that seems to be only going up and no sign of turning. And this observed warming is due to atmospheric concentrations of carbon dioxide, methane, and nitrous oxide that are at unprecedented levels since the mid-20th century, all kind of driven by economic and population growth. And the estimates are that humanity is pushing out 50 billion tons of greenhouse gases every year, and that's more than nature can absorb. It's causing a blanket of carbon in the atmosphere, heating the planet and changing the climate. Again, the trajectory is heading in one direction at an alarming rate, and science tells us that the results will be catastrophic. There's plenty of evidence that the abundance of carbon and greenhouse gases is causing this rise in global temperatures. And I've listed here some of the things that are causing grave concern and really compelling reasons why we must act now. So it's not an exhaustive list, and many of the topics are kind of interconnected. The number of record high temperature events have been increasing, while the number of low temperature events has been decreasing. And we are witnessing an increasing number of intense rainfall and severe storm events. So climate change is behind the surge in wildfires and droughts. Fires are becoming worse. The rise in temperature has caused an increase in evaporation, making the ground and the vegetation in forests drier, so they burn easier and faster than ever before. We are seeing land loss due to ice melting in places like the Arctic, Greenland, Antarctica, and snow is melting fast in the mountain tops, and it's draining more water into our oceans. This in turn has led to a rise in the sea level, which then puts coastal cities and towns at the risk of flooding and land loss. There's increases in temperatures and rain patterns, and this is causing a spread of deadly disease-causing insects. As the temperatures go up, they can expand in numbers and then spread beyond their current habitats. And then species and vegetation are dying because land is being lost. The forest is burning, and the problem's excessive pollution in the air and water. And then the acidity of surface ocean waters has increased about 30% in recent decades. Microsoft supports all the UN goals around sustainability, but it's primarily focused on environmental sustainability in these four areas: carbon, water, waste, and ecosystems. And then back in January 2020, we announced this kind of bold commitment and detailed plan to operate with 100% renewable energy by 2025, and then be carbon negative by 2030. And then we built on that pledge with a series of kind of commitments to be water positive and be a zero waste company by 2030, and then provide support for a number of biodiversity projects and conservation ecosystems to ensure we protect more land than we use. Now, when it comes to carbon, there are three categories of carbon emissions, or what we call scopes. Scope 1 is your direct emissions. So example is the vehicles that you use from going one place to another. Scope 2 is the indirect emissions caused by the production of energy that you use. So for example, the energy used by the lighting in your buildings. And then scope 3 is any other emissions, and including across all your supply chains. And that's the hard one to control. And then the Microsoft commitment is to address and include all three scopes. And that's why being carbon negative is such a bold commitment. We saw in the opening video, Microsoft are building a planetary computer. It's a platform that will accelerate environmental science and provide access to trillions of data points about the planet Earth. So it provides insight into complex questions needed to make smart decisions about air, water, land management that are really difficult to answer today. We see water inextricably linked to carbon. It's a byproduct and necessary ingredient for many industries, but it's a necessary ingredient for life, and that means conserving water in industry kind of leaves more for people. Water positive means that we will replenish more water than we consume. And then with waste, it's about understanding every material we use as it comes out the ground all the way through its kind of life cycle to end of life. And then thinking about the sustainable choices that we can make through that cycle. Zero waste means addressing our operations, products, packaging. Waste will not end up in landfills and incinerators, and we will eliminate single-use plastics in all our packaging. And then devices like the Surface will be 100% recyclable. Now, things don't happen overnight, and this is a journey, but we as Microsoft are well now on that road to start to deliver on those commitments. Climate change is one of the greatest challenges for mankind and in our lifetime. And then as software engineers and application developers, we can play our part here. We all need to be on board and encourage and help everyone to build and deploy sustainable software applications. And there are kind of three things that we can do. Move to the cloud, think smarter, and then adopt philosophies and competencies of green software engineering. Now let's look at each in turn. I've obviously got interest in promoting Azure, but I think it is fair to say that all hyperscale cloud vendors have got the same concerns and are investing heavily in initiatives around sustainability. So all of our compete clouds have all made their own commitments and working on their timelines. And you're going to need to go to each one of those to see how they compare to Microsoft. All I'll say is that Microsoft feel really proud about our commitments and the way what we are achieving compared to others. Now, what is clear is that any hyperscale cloud vendor, including our competitors, will have substantial R&D budgets to ensure that they can reduce carbon emissions and be more energy efficient than what any enterprise organization could ever achieve on their own with their own on-premise data centers. That's for the same kind of workload. Now, what we found was that transitioning workloads to the Microsoft Cloud services could be up to 98% more carbon efficient and 93% more energy efficient than the on-premise equivalent. Obviously, it depends on a number of factors, and that is documented on that link there, an independent study by WSP that kind of explains that. So when businesses choose Azure, they are taking positive action to reduce carbon emissions, and it's a compelling way to contribute to the climate goals of any company. Okay, think smarter. So technology has the potential to contribute to addressing environment issues. As organizations use technology to drive business value, they can also think about enabling smarter growth and to transform sustainably, and perhaps can even create new business models. So there's innovation in data acquisition and analytics with artificial intelligence and advanced robotics, as well as cloud computing, satellite and mapping imagery. And it's all opened the doors to many solutions enable optimal decision making and for driving efficiencies, so ultimately saving carbon and energy. And I know some organizations on this call are actually involved in smart infrastructure, so things like smart cities, smart transport, smart buildings, and using technology to measure and minimize carbon emissions, water consumption, and waste. In a previous tech talk we did on IoT, we looked at digital twins, and this is where you can create rich models of anything physical or logical, and then building applications to use those. So an example that I've seen is the kind of using this technology for the detection of water leaks, and that obviously is key in helping to save water, or combining digital twins with predictive analytics to reduce energy use. And there are examples of using satellite imagery and machine learning to inventory land and help conservation projects. Technology can drive efficiencies in business processes and supply chains. So perhaps it can save paper, perhaps it can save travel with digital collaboration. Robotic process automation. This can improve process accuracy, reducing defective products, reducing rework, cutting down on wasted materials, and therefore that extra energy and inputs to rework a process or to remake a product. Another interesting example is Azure FarmBeats. It's an agricultural industry solution, and it uses technology, it uses artificial intelligence, it uses machine learning to cut costs, increase yields, and then sustainably grow crops that are more resilient. And then the last thing, something that's on the horizon, quantum computing. This promises to solve many complex problems that classical computers would just take too long to complete. Quantum simulation and problem solving could enable new thinking and help people make educated decisions around physics, chemistry, and then environmental science. The third thing I kind of called out was green software engineering. So this is an emerging discipline with principles, philosophies, competencies to define, develop, and run sustainable software applications. So green applications are normally cheaper to run, they're more performant, they're more resilient, they're more optimized, but that's just a kind of welcome addition. The key thing is developing applications in such a manner that will have a positive impact on the planet. So you need to be thinking about making code changes, architectural changes, choices that actually reduce carbon emissions consumed by the application. And with that, so that's my intro. I'm going to now pass on to Paula to kind of go deeper into the topic of green software engineering. So,
hi, Mark. Thank you. Hello, everyone. So thank you, everyone. My name is Paola. I have been at Microsoft for about five years, something like that. First, I was a cloud solution architect at AppDev, as probably most of you are today, and now I'm a team manager. I'm a season manager. So I'm here because I wanted to talk to you about some of the collateral activities. One of them is this green software advocacy. And it's an activity that started about a year ago when I was trying to find a link between software and sustainability. And it all started as often happens to me with a book, which for me is always a nice gift to give. So the book is Overstory. I think it's also in Bill Gates' reading list this summer, so it's becoming famous. But this book is a story, a bunch of human stories. They're intertwined with the trees stories. And reading this book, I found out that there's an entire discipline that deals with the understanding how the trees in a forest communicate with each other. They protect themselves, and they're even able to pass nutrients to the weakest individuals of the forest. And so with this book, my green spirit revamped, and I was prompted to find some additional meaning to the daily work. And obviously, I am an electronic reader, so no trees died for this cause. So let me give you some numbers, because the introduction that Mark did about the global warming situation is true. It's a very important issue. It's probably the most important problem we have today as a global community. We must reduce emissions and we should be zero emissions by 2050. So that is the solution to all problems. But let's go and see what happens in our data centers, which is where we work. So first of all, the demand for compute power is growing faster than ever. And we know it because we are pushing customers to go in the cloud. Here's the catch. Data energy consumption is about a fifth of the global electricity usage, or it will be by 2025, so we're not far from that. But you know that because you work with your customers that a virtual machine operates at 20–25% of capacity if we're lucky, but still consuming a lot of unused energy. And on the other hand, in an instance where I have applications and running using physical hardware, it's still necessary to keep the service running. And you have to use resources regardless of the application being idle or actually doing work. We have containers, which obviously are a big deal to capacity and to density of a VM. We can reach 60% or higher. I have seen some illuminated customers doing 60%. But in the end, if you're being honest, probably 75–80, up to 75–80% of the world server capacity is just there sitting idle, consuming electricity and resources, basically for no reason. So what can we do? The starting point is a website. I will give you the link at the end of this presentation, where a community of developers and advocates is trying to create guidelines and help creating even standards to write sustainable code. I will go quickly through all these principles, but you are encouraged to go and study them yourself. So the first one is the first step towards sustainability, carbon. So sustainability of an application should be the general target. And it seems trivial, but to date, there is not much documentation in computer textbooks or websites. Second principle, electricity. Most of it is produced from fossil fuels and is responsible for half of the carbon emitted into our planet atmosphere. All software is using electricity to run, from the app on the smartphone to the machine learning models that we run in the data centers. But developers generally don't have to worry about these things. It's someone else's problem. It's been someone else's problem. What we're saying here is a sustainable application must take charge of the electricity consumed and be designed to consume as little as possible. Third principle, carbon intensity. This is the measure of how many carbon emissions are produced per electricity consumed. Electricity comes from a variety of sources with different emissions in a lot of places and at different times of day. And most of all, when we produce it in excess, we have no way of storing it yet. Fourth principle, embodied carbon or embedded. This is the amount of pollution emitted during the creation and the disposal of a device. So an efficient application must run on older hardware, also to have a good impact on emission. Fifth principle, energy proportionality. The maximum rate of server utilization must always be the primary objective, and we will see an example later in this presentation. In general, in the public cloud, this is also equal to cost optimization. As Mark was saying, these type of applications are greener and cheaper, so it's a win-win situation. The most efficient approach is to run an application on as few servers as possible and with the highest utilization rate. If we use PaaS or serverless, even better, because we know that someone else is taking care of the utilization rate for us. Sixth principle, networking. We need to reduce the amount of data and the distance that data travels across the network, because it will have an impact on the environment as well. If we optimize the route of network packages, then we also reduce the use of the servers that are run to pass those networking package. Networking emissions also depend on many other variables, like the distance crossed, the number of hops between network devices, the efficiency of the devices, even the carbon intensity of the region at the moment that data is transmitted. So basically, we need to play it safe and be wise using networking. We cannot waste bandwidth and send data across the network for no reason. The seventh principle is a very interesting one because it's also related to the end user interface and the availability of the chance of creating a new conscience, a new way of doing software. So instead of designing a demand-based application, if we are developing in green software, we will get demand from the energy supply. So with demand shifting, we can think of moving workloads to regions and at times when there is a lower carbon intensity. So if I have a data center, for example, in the south, probably at night it might be cheaper to run because during the day the sun is hot, the air conditioning must be high, and everything is correlated. With demand shaping, on the other hand, I can involve users and I can separate my workloads so that they are, first of all, independently scalable. And this is, by the way, any reference architecture you will see from Microsoft, any native cloud architecture is with microservices, each are independently scalable. But the point here is I can prioritize them and support the features based on the energy consumption and based on the moment that this is done. So when the energy supply is low, the carbon intensity is higher, and the application can reduce the features to a minimum. Let's call it a green version of the application. And I can involve users in the choice by presenting them the green option with this minimum feature set. And this is something that customers are liking very much. The eighth principle is measurement and optimization. Energy efficiency must be measured, of course, in all parts of the application, and this is mandatory to understand how we can then optimize it. For example, would it make sense to spend 2 weeks reducing network communication by a few megabytes when I have a full scan DB query with 10 times the impact on the other hand? So we need to know the overall consumption, the overall efficiency of the application. As an example, I was mentioning earlier, there's a blog site, I will give you the address later on, where a bunch of fellow green software advocates are writing a few articles. And in one of them, in many of them actually, we state that serverless architectures are the best because they are highly optimized and efficient, and we start to have good examples of it. One of the examples is Azure.com. So we adopted this logic as Microsoft and decided to optimize the data pipelines of this Azure.com site with a special focus on carbon and cost saving. The Azure.com website is quite popular. I am sure you all know it. This is the site that I personally use every day when I look for Azure documentation, or I have to know how much a service costs, a specific service or architecture costs, and so on. This is not the management portal, but it's the CMS of the whole Azure world. And I mean, this site is pretty popular also for pages like the product by region, or again, as mentioned, the pricing tool. This site has also a service level of 99.99%. The history is we started with an open source CMS in 2013, and then in 2015 we switched to a custom ASP.NET MVC application hosted on Azure. So we moved to the cloud. And from 2020 we introduced this green architecture, the leaflet that you can see on the graph. Let's see what's it about. So the decision was driven, as I mentioned, by cost and carbon savings. The decision was to migrate all the data pipelines from a dedicated, always-on app service web jobs to serverless, so functions. There was also a goal of simplicity of design, because if you see the two architectures, the second one, which is the target, is much simpler and much nicer. The one before the change is a quite common one. Each data center hosts its own data pipeline that integrates external data. And the data pipelines are performed in a single, today the data pipelines are in a single geographic area and are using a shared service bus for business continuity, so first change. The architecture also summarizes all the workflows before and after refactoring. The data pipelines are data entry workflows that take external data stores and ETL on local regional data stores. We extract data from an external store and transform it into a local store, such as a Redis cache or a storage blob for the page rendering layer. So nothing tricky, nothing fancy. A few more details on this change. Where possible, we used a push data model, and this was to reduce the unnecessary API calls. This compromise, though, required a tighter coupling with the external system. So we had to use a pub/sub model on the service bus. But then the advantage was economic saving, as now we use resources only when needed. Previously, we were using cron jobs to ping API endpoints, even when the data did not change. And in some cases, we were updating all data targets unnecessary. After adopting functions, all the legacy web part has been deprecated, and this reduced our spending by 10 times, roughly, and our carbon consumption also by 10 times. Also because we no longer have these useless cycles without performing operations or updating data without changes. And as I mentioned earlier, this approach is consistent with the fifth principle of energy proportionality, because we are maximizing the usage levels of the application by using an elastic service based on consumption. Also, it's a simpler design approach. We had a few issues on the scalability. For example, the interruption of messages due to the limitation of the service bus endpoint. This was solved by horizontal autoscaling of the service bus. Also, there were some network usage issues. So we had to reduce the chattiness of the function. We have the chattiness between the function and the service bus interface to improve the data throughput. So what came out of this experience is serverless applications are natively designed to optimize emissions, because first of all, they are natively designed to optimize costs and usage of the servers. Also, because the same application at different time consumes differently depending on the place and time of execution, demand shifting is a technique that can be easily applied to serverless architectures. We have no control over the infrastructure used, we know, because it's a serverless. We don't do anything on the infrastructure, but we can trust that the cloud providers want to use the resources at 100% capacity. Another important point is cost optimization. This is the first indicator of sustainability. And with serverless, we can have this direct impact on execution times, on the network data transport, and in general, building a more efficient application. Serverless is basically using only on-demand resources. At least this is how we develop here. I know that there are plans where it's half serverless, but this is what we did with Azure.com. We already know that the density is the highest possible here, and workloads are ready to do demand shifting and demand shaping techniques. Out of the discussion and of the blog came the Green Software Foundation, which was launched in the 28th of May this year. And this is a non-profit organization managed by the Linux Foundation. Its mission is building a trusted ecosystem of standards, tools, and best practices for building green software. And it's an association between Microsoft, Accenture, ThoughtWorks, Goldman Sachs. You see the members here. This was born out of the need to collaborate in the software industry with a shared commitment to sustainability and an interest in green software principles, green software development principles. So every company is encouraged to join. We already started the work with the colleagues Azim Hussein and other people at Microsoft. We are working on several tables, the innovation, the standards, so there's a lot to do. And as Mark was saying, this is an emerging discipline. What we expect is by the end of this year, we will have standards, rules, tools, measurement, a bunch of tools to give to the developers for them to start writing green software. There's an impact that developer can have immediately on application sustainability, and I have put together just a bunch of best practices here that are a starting point, a starting discussion. So if we make a program more accessible to older computers and devices, if we exchange less data, and we have a better user experience, by the way. If we try to collocate microservices that are highly coupled, we reduce congestion and latency. And I mean, these are all best practice to any good application, by the way. We should consider running resource-intensive microservices in regions with less carbon intensity. This in Europe is not so easy. It might be easier in the US because data, GDPR, whatsoever, but it's still possible for some workloads, especially when there's no data involved. And optimizing the databases, that is also a key, because if we optimize data, then we can reduce the energy to run the databases and idle times and completion of queries. In many cases, web applications are designed by default with very low latency expectations. And we expect that a response has to occur immediately or as soon as possible. But this sometimes is not necessary after all. So we should evaluate whether latency limits can be somehow eased in some areas of the application, and this might also help reduce emissions. Serverless is probably, in my opinion, the future of native cloud, not just because it's beautiful, but also because it has the least impact on emissions. And last but not least, these are some links to get you started on the sustainable software engineering, and let me know if you have any question.
Thanks, Paula. Fantastic. Let me just do a couple of slides to wrap up, and then what we'll do is we'll open up the mics as we normally do. So just let me wrap up. These are the links to our learning paths. I've also included some of these sustainability links. I guess they repeat some of what Paula had as well. But you know, our learning hub is a place for learning content and modules and learning paths and information around Microsoft certifications. And there's a curated video platform as well called Learn TV. So that's where to go to get more information. This is where I normally post my agenda for the future AppDev Tech Talks. At the moment, it's looking pretty empty. I'm going to let the summer pass, and then we'll react to some new ones, maybe from September. Now, there is, as we kind of hit our new financial year, there might be a realignment of accounts to me. So it might be that some of the people on this call will be aligned to some of my colleagues. So they may get invitations from them rather than me. If people still want to attend my Tech Talks, then I'm going to start publishing a kind of schedule on that link there. So kind of closing, we'll open up the questions mics. Feedback is really useful for me. It helps me get people, experts like Paula. So if you can send me feedback about today, it just really helps me get people involved. And then ideas for content is useful as well. Helps me schedule up an agenda and deliver content and what people want to hear. Recording and slides will be made available as usual, and that's the end. That's my content. So let's open up the slides. So let's open up the mics.
I see already a question in the chat. Carbon intensity of Azure data centers by service. Where is this data? Can it be displayed in the Azure portal when selecting a region? You're right, the data is not there yet. We are working on it. But bear in mind that our approach is on the application side, meaning we had this huge discussion with the data center people. The data center guys say, hey, once I switch on the data center, the electricity is there. There is nothing I can do. I mean, it's not that I switch it off. So I am consuming energy, whether you use it or not. So the shift we are doing here is on the application side. We're saying, hey, let's create better, more efficient applications so that I can use better this data center, which is switched on anyway and consumes tons of electricity and carbon. Blockchain contain. I know that this is very ungreen. This is everything that we read about blockchain is that it consumes a lot of energy. But this brings the discussion back to the data center, meaning that the data centers, this is infrastructure and it's switched on anyway. So it's somehow up to the data center people to optimize it. We developers should optimize the application using that infrastructure. At least this is the sustainable software engineering purpose. I hope I answered your questions. Most organizations are driven by short to medium term profitability. How do we show green is cheaper? This is an excellent question. So what I found out is I have been involved now in probably 20, 25 discussions with customers, with large customers, S500. They are interested in SSE because in green software, because sustainability is now a keyword for funds and money in Europe. So we have a lot of money that is linked to sustainable projects. So everything that has a green tag right now gets funding approved. And so this is also why customers are very interested in this topic, and you will find a lot of green fields to work with. How do we show green is cheaper? There's another question. How do we show green is cheaper? Well, we can show that an application is cheaper by optimizing it in the cloud, and that is out there. The current tools to measure the carbon impact of an application in Azure rely actually on the cost API of Azure. So basically, we're saying the same thing, that if you optimize an application for cost, you're also optimizing it for carbon. At the moment, when creating an Azure resource, you select the region you are deploying into. With demand shifting, how might this work in the future? Selecting a range of acceptable green region with Azure moving the workload around? This is a very good question. I don't have the answer right now. I know that there's a study which you can find on the web, which is a Kubernetes carbon scheduler. So this would be up to the customer to decide where to put the containers. And of course, this only applies to stateless objects, things that you can move between sites. And again, in Europe, we have a slightly different setup, which I think it will be very difficult to move workloads from one side to the other, at least in Europe. But the demand shaping, that is a very good point, that nearly every customer that I spoke with was happy to start working on. The demand shaping, meaning defining a minimum set of features where your application runs the grid version of it. No other questions?
we'll draw a line under the date. Thanks, Paula, for joining us. Really interesting. And
thank you for your time, and I'm happy to answer any further question.
okay, we'll call it a day. So have a good weekend, everybody, and I'll see you again hopefully shortly. Speak soon. Thank you. Bye.
Thank you. Bye-bye.
Yeah.